Okay, I'll try to do a couple of these. Find the inverse of a really, really ugly function. So finding the inverse, step one is always, always, always to change it to y, which means I'm going to have to rewrite this a bunch of times. So y equals 7/6 of the quantity x minus 10 close parentheses to the 2.6 power, and you'll notice you have an open, open, close, close, plus 1. So step two is always, always, always swap x and y because it's an inverse. So we've got x and we've got y, and everything else is going to be exactly the same. So equals open parentheses 7/6 open parentheses of y minus 10 close parentheses to the 2.6 power plus 1. Okay. So, not a big deal. Now we just solve. So I'm going to subtract 1 from both sides. And I now have x minus 1 equals open parentheses 7/6 of y minus 10 close parentheses to the 2.6 power. All well and good. Now I need to get rid of that exponent because I can't touch the stuff inside until I get rid of it. How do you clear an exponent? Well, remember that, and this is teaching point, when you are multiplying the bases, you add the exponents, right? Equals x to the third. When you are dividing the bases, you subtract the exponents. And when you have parentheses, x cubed to the fourth power, you multiply. So since we're going to multiply, if I wanted to clear that x cubed, I'd multiply by x, but the 1/3 power, and I would have x, which is what I need here is to get rid of that. So having said all that, I am going to use my parentheses, and I am going to raise each one of these to the more parentheses 1/2.6 power, because I can. So now I've got, on the left side, I've got x minus 1 to the 1/2.6 power. And just remember, that's just a number. If you put it in your calculator, it would equal 0.4-ish. I don't even know. I'm making that up. It would equal something. And that will get rid of that. That'll put the whole thing to the first power, which will kill a lot of our parentheses. Thank goodness I won't need the parentheses that the exponent are on because the exponent is gone, because that's equal to 1. So now I've got 7/6 to the y minus times the quantity of y minus 10, which is good because now it's just straight up math. Well, it always was straight up easy math. So I'm going to multiply both sides by 6/7 to clear the fraction. And here we go writing a bunch of stuff again. You'll spend a lot of time writing stuff as your equations get more and more complicated. And you'll spend a lot less time making mistakes because you will not want to do that. So now, the 7 and the 7, 6 and 6 canceled. I've got y minus 10. And my last step, finally, is I will have 6/7 times x minus 1, the quantity raised to the 1/2.6 power. And I added 10 to both sides. Yeah. I probably should do that. And I'm going to add 10 to both sides. And so plus 10. And that's going to equal y. I'm not going to write equals y. I'm going to write equals f to the -1 of x, because that was where I was going the whole time. But it does equal y. So what I'm saying is that that is so cool. I gotta fix that. What I'm saying is that given this function, given my original function, there's my inverse. Okay, And if I graphed them both on Desmos.com, I would find that they were symmetric around the line y equals x, assuming I could draw a straight line, which would go through the origin and all that good stuff. And they would be symmetric about that. I don't have Desmos queued up, but I will check it. And if I post this video, that means it worked. Have a great day.